Program funding for the Organic Odyssey was provided by the California Certified Organic Farmers Foundation, as well as the Transition to Organic Partnership Program. Visit their web pages or social media for all their amazing content and guidance on everything organic. Support for the Organic Odyssey is provided in part by the Grimm Family Center for Organic Production and Research at Cal Poly. For more information or to support the center, please visit organic.calpoly.edu. That's organic.calpoly.edu for the Grimm Family Center for Organic Production and Research at Cal Poly. Support for the Organic Odyssey is provided in part by AgCom Central. Visit AgCom Central on twitch.tv or youtube.com for all content ag-related. That's AgCom Central on twitch.tv or youtube.com for AgCom Central.
Welcome back to the Organic Odyssey. I'm your host, Madison Jasso. Today we're in a little bit of a different scenery. We are at Swanton Pacific Ranch, and we have two guests here with us today. If you want to introduce yourselves.
I'm Greg Rawlings. I work with Jacobs Farm del Cabo.
And I'm Matt Grieshop, Director of the Grimm Family Center for Organic Production and Research. And it's a real pleasure to be out here in the beautiful Santa Cruz environs and in the field.
Today we're going to be talking a little bit about how Mr. Rawlings got started. So how'd you get started? What was your journey through it all?
I was a double major of chemistry and biology at UC Santa Cruz, and I was actually working, the one that made my direction is I was actually working in my OChem lab, my professor's OChem lab, making Taxol, which is an anti-cancer drug. But over the time I'd watched, just a lot of pollution and a lot of, stuff in there. So I was thinking, as my brain thought about it, I was thinking, well, we're making all of this pollution to try to find the solution to all of the pollution, So, just pollution causes cancer, and then we're causing more pollution to fix the cancer. And then, so I kind of just decided that I wanted to do something different than organic chemistry. And I was, at that point, I was just majoring in biology and had a chemistry minor. And I went, and it was kind of a lifestyle choice of either wanting to organic farm in this area, in Santa Cruz area, or doing wildlife biology, which would probably mean going to like Wyoming or Montana or something, And I just decided that I wanted to live in California. Wow. So, and then I started at Swanton Berry Farm right up the road here, selling strawberries and then working in the fields.
So is that what you do now? Just
so that was in '95 I started working at the strawberry farm, and in 2004 I started my own farm for a while, Blue Moon Organics, and we made it until 2011, and then I got a job with Jacobs Farm, and I've been farming ever since then at Jacobs Farm. And Jacobs Farm is, we do mostly culinary herbs. So if you go to like Trader Joe's or Safeway or Raley's, you will find our culinary herbs in their names. So it would be like O Organics and Safeway or the Trader Joe's brand. And we also do some vegetables like dry farm tomatoes and some pumpkins. And then the other side of the company, the Del Cabo side, does cherry tomatoes and other vegetables from Mexico, and they bring them over. So the border, yeah.
And Jacobs Farm has been a long time tenant here for the Swanton Pacific Ranch. How many years has it been now?
I think I was working for Swanton Berry Farm when this came up, and Jacobs got it, and I want to say that was in, it must have been 2001, 2002, okay, 2003, something like that.
Yeah, so that's pretty early in Swanton Pacific's history as well. The initial donation from Al Smith, I think, was '93, okay. and so I think things really started getting going in those late '90s. So yeah. That's a really long relationship.
Yeah,
it's excellent.
Definitely.
Yeah. So how about here at this farm? What are you all growing? I mean, what are your major crops here?
Right now, at Swanton Pacific Ranch, it is really it's one of our locations where we can do the dry farm tomatoes, okay, which is a very successful program. Dry farm tomatoes are a tomato that you would water I mean, there's some purists that will only, water. They won't water their dry farm tomatoes in. They'll wait for the last rain and then they'll plant the tomatoes.
Right.
We water the tomatoes in, and then we don't water them again.
Right.
So, in order to get them to set into the ground and then to start the taproot going down to find the moisture table as you go, we plant them at this location. We plant them in April, and then water them in, and then we harvest them usually in October and September.
That's great.
So it's a long term. We're definitely right on the edge of where you can grow tomatoes. There have been years. One of the interesting things about this farm is we do get some floods, some inundations here, and with some of the changes in the riverbed by the NRCS to kind of tie the flood zone back into the farm, back into the flood zone, we're getting some areas where we're getting inundation for too long, and it's killing the soil biology. So there was 2 years ago where we planted some dry farm tomatoes where I think we planted 6 acres, and like an acre we never even harvested. We had to pull it out before it was even harvestable because of the late blight, which is just a disease that's common here. And every year you get late blight on your tomatoes, and and it's kind of a race to get your crop out before the late blight really hammers your tomatoes too much and kills them. And every year you were really successful, except for that 1 year where we just that particular block 5-2 was too wet for too long, and we killed the soil biology in it. And it was just amazing how, right in that corner of that field, the late blight was just out of control. But as you just got farther away, to where the soil wasn't inundated as long, you have the good soil biota in the soil, and it was, protecting the plants from the late blight in a lot of ways.
And just for our audience, in case you're curious, so late blight, it's Phytophthora infestans, and it's actually the Irish potato famine was caused by late blight. So if you have Irish relatives that came over during that time, the same disease was kind of a causal factor for that, and it thrives in wet soils. It's what's called a water mold, I've witnessed collapses of whole tomato fields to late blight, and it's always pretty soul crushing.
because it's so fast, right?
Yeah.
I mean, it's like one day, everything's great, and then a couple days later, everything's just collapsing. And,
it can be that fast, yeah. And in that place, it wasn't quite that fast, it's because we're so close to the ocean and we get so much moisture overnight and stuff. Typically, anytime you see dew in the morning, you having some late blight transmission, because it generally, there's so many spores for late blight around here that it needs about 12 hours to germinate into the tomato. So, and often it'll germinate into the leaf first, right? Because it's much more fragile than the tomato itself. So right now we're doing a lot of tomatoes here. We also do some dill and cilantro at times, and some thyme, and we have some rosemary. Although there has been some water table problems in this valley, starting in, there was a drought when I started here in 2011. And then I think 2012 or something was a decent water year, and then there was another drought between 2013 and 2016. And what was happening was, as the drought continued and intensified, the water chemistry was getting more and more. There were more and more iron in the water, and more and more manganese. And it got so bad that when I started here in 2011, we probably had, I would say we had 80% of our rosemary at this ranch. Probably like almost 20 acres of rosemary across this ranch. But as the water chemistry was getting worse and worse, rosemary, underneath the leaves are all these oil glands. And the iron is dissolved in the water, but it's only dissolved in the water until it hits oxygen. And then when it hits oxygen, it kind of comes out and it looks like rust. And I don't know if you can see around here, but a lot of the times, like the sprinkler heads and stuff are here all rusty. They look rusty even though they're aluminum, and they're not rusting themselves. It's because the iron in the water has come out, and it like changes that color. But what was happening with the rosemary was that we were overhead watering the rosemary, and then underneath the leaves was soaking up this iron color. So we eventually got rosemary with, green leaves on top and fluorescent orange leaves underneath.
Wow.
Completely unsellable, completely unmarketable, because
Right.
I wouldn't want to eat it. Nobody wants to eat that. So one of my first main things was moving all of the rosemary from this ranch to other ranches as we, because of the water quality issues in this particular farm.
So I'd never heard of that before. That's really interesting. So the iron deposition on the underside of the leaves, does that affect the like culinary qualities of the herb as well as the appearance, or was it more of an appearance thing? Do you know?
We never really tried to sell it.
Well, yeah. Right.
Right. So I don't know that we tested whether it had culinary effects
Yeah.
so much or flavor effects, because it's just it was so obviously wrong to try to sell it that we didn't try to sell it. So, but we did try to do, I guess the one surefire way of getting the iron out of the water is to build a big reservoir, have your water coming in, have it like come down these little waterfalls so that it makes the iron precipitate out and then pump from that reservoir out to your fields. Of course, that's, a couple $1 million to do all that. So, not money that us or the university has at this time. But we did try other methods, like, there were, magnetic field things. Oh yeah, just not. Worse, if anything. So none of those other methods worked as far as I can tell.
It's kind of like those magnet kits they say to improve gas mileage, right? You stick it on your fuel line and it magically does something. Right.
It means nothing.
Yeah, exactly. It made somebody some money, I guess, and but not you.
Not me.
Yeah.
So right now we're really doing the dry farm tomatoes here, dill and cilantro sometimes. We're going to get probably more into those in the falls again. We grow, luckily in this region we have 6 farms that I manage. We have 3 in Pescadero, 2 in Wilder here, and 1 in San Jose. So we have a lot of different microclimates.
Oh, nice.
So you can kind of like, and I have, crop plants all year long, but much less in the winter. It's, really focused in, between April and December. But because I have these ranches and I can, put the best crop system, at the best time in a best ranch, so, this ranch particularly is really great for fall dill and cilantro, where it's a little bit too wet down at Wilder, but it's still too hot over in San Jose.
Right.
So there's there's this perfect window for dill and cilantro here. Thyme does really well here in the fall. But we're still dealing with some of those water situations too, so we're trying to get back into some of these things here. So, but in a way, if we were a smaller farm and we were only at this location, it'd be much more stressful because it would, because I would have to deal with that water on every crop, and I would have to deal with, all of the particulars of this ranch on every crop system. Whereas, I'm lucky in the sense that I have 6 places and I can, pick and choose where I want to put things. So, even organic farmers often don't understand, and even though one of the basis of the organic movement is feed the soil, not the crop. Even many organic farmers don't really understand what that means. And what it exactly means is don't put any soluble nutrients in your soil. That's what I've learned. So back when I was a very brand new farmer, fertigation came out, and it was a big, fertigation, in case you don't know, is putting nutrients through your irrigation lines. And Swanton Berry Farm is kind of known for great tasting strawberries, and but when you're growing some of the varieties that taste really good, often the yields are a little bit lower. So you have to get a higher price. You have to, figure out other ways to make a decent economic living for yourself. And so one of the things is you're always trying to raise the yield, and this fertigation came out, and I was excited. I was like, yeah, this is going to be great. We can increase our yields. So I started it, and you know what? Yields went up. I mean, it was amazing. There's big fruit, like bigger fruit than we had in the past, and but at the same time, they tasted like shit. And I was just like, why does this fruit taste so bad? Every year it's been so good and now it's so bad. And I was complaining to my boss at the time, like, well, yields are up, but I can't even eat the berries, they're so bad. He's like, oh, well, after like a month of this, he was just like, well, when I was learning, the old guys, a month of me complaining to him about the flavor and how I was, what was going wrong. And he's just like, well, guys down in Salinas Valley, when I was learning to grow strawberries, they said, don't put in too much potassium, it'll make your berries taste bad. I'm all like, oh, well, I've been irrigating with potassium, so I cut the potassium out. And, and I found, there was this one, so I cut the potassium out, the flavor improved somewhat, but not nearly what we had in the past. But while I was doing it for that year, I kind of figured that, every time I fertigated, I could taste it in the fruit within like 3 to 4 hours.
Oh, wow.
And the flavor got worse every day for a week, and then it got better. And then a month out, I couldn't taste it anymore. Huh. So I could taste it. If I fertigated, I could taste that fertigation in the fruit for a month.
Interesting.
And what the thing is that everybody else can too.
Yeah.
They just don't know what they're tasting.
Right.
So when people go now and they taste strawberries, just a normal store-bought strawberry, and they're like, this is just not very good. And it's what they're tasting is the soluble nutrients in the fruit. And it makes the fruit grow really fast. It makes the plant grow really big, but there is no, at the same time, it's breaking down the symbiosis between the plant crop and your microbiota, or your fungal, your bacteria and your fungus that is actually the root of organic farming. Is we need that symbiosis between the plants and the crop in order to get a nutrient dense, good food that tastes good, but it also tastes good to yourself, right? Like, so while I was fertigating, I knew without the potassium just makes it taste bad no matter what.
Okay.
The nitrogen and the phosphorus, had this 30-day window, which is, interestingly enough, the same amount of time it takes for a strawberry flower to turn into a fruit. So if you fertigate while there's a flower on that plant, I can taste it when that fruit comes.
You're kind of setting the course for that piece of fruit.
Yep.
Yeah. Wow.
So, but because I was doing it and I was tracking exactly what the flavor was doing, that's one of the things I realized was that, the soluble nutrients are really ruining the flavor. And I didn't really realize at the time they're also ruining the pest resistance and the disease resistance of the soil.
That's a classic story, especially for sucking insect pests like aphids or lygus bug. You increase nitrogen load in a plant, it increases free amino acids, which is what those insects really want. That's their candy. The sugars that they get out of plant sap it's not useful for building more lygus bug or aphids. You need protein to do that, and that means nitrogen. Right. So that's really fascinating. So what were the big flag pests that you saw in response to that?
Well, it was, we had spider mites.
Yeah, T-spot. Yeah.
But I didn't really realize, and we didn't. I'm trying to think if we even sprayed back then at Swan. I don't think we did at Swanberry Farm.
Right around the time that biocontrol releases were. Well, no.
Yeah, we did. We definitely did. Persimilis.
93, 95 was when that really started, I think.
We did a lot of Persimilis releases. But
Persimilis is a predatory mite that eats the plant-eating mites.
Yeah, they're cool.
Yeah, they are really cool.
But the other thing is that I didn't put together at that time. I put together the fact that soluble nutrients ruin your flavor.
Okay.
And that flavor is tied to health and nutrient density, which is tied to health. And that everybody has these incredible, taste buds that will tell you what's, healthy for you and what's not. And if you don't, and if you get too many soluble nutrients, that's often why produce doesn't taste good right now.
That's fascinating. I'd never put that together, but
it's it's one of the things I learned. The other thing that I learned about the soil biota and how important it is to not use any soluble nutrients is because it's an exchange between the plant's crop and the soil nutrient and the soil biota, right?
Right.
So the plants are exchanging carbohydrates, sugars with the soil biota, and the soil biota is mineralizing the organic matter and the rocks and bringing the nutrients to the plant. So if all of a sudden the field is flooded with your soluble nutrients, ammonium nitrate being the most common, the most problematic, the first thing the plant does is it realizes that it doesn't need to pay anything anymore for these nutrients. So it stops paying, it stops bringing the sugars down to the soil biota. And the soil biota, no longer having a source of energy, starts to degrade.
Right.
But the plants themselves all of a sudden have, I don't know the percentage, what is it, 10%, 15% more energy from themselves. So they get a boost. And this is the green revolution.
Right.
They put in these soluble nutrients, the plants grew great, at least at first. But then you realize, as, like you were saying, as soon as you get that one field, with all of that green, nitrogen available, all of a sudden you get these flying pests. You get the aphids, you get the insects that come in, and because they can detect that from miles away. So you're now ground zero for all of the pests in your area. And the other thing about not having a decent soil biota below hand is that they've done studies where there'll be a greenhouse and they put another little greenhouse inside, and they put insect pests in that one little greenhouse, and within a couple hours the whole field is making allelopathic chemicals against that pest. Whereas, so in an organic field, if you get insects in one side, the whole field knows, and they're all start to produce these chemicals against it. Whereas if you're in a conventional field, there's no longer that interconnectedness below the ground. So they don't know, there's no information transmittal. So every time every plant is getting attacked, they don't know until they get attacked that there's a problem in the field, right? Because they aren't in contact with their neighbors. In an organic field, they're all in contact, so they all know,
So it's kind of like a smoke alarm.
For a fire, right?
Yeah.
Well, and a modern one, right? In a house, they all go off.
Yeah.
I'm not a great cook, so I know that. Yeah. But yeah, that's really interesting to think about. What about, so you talked about late blight earlier. That's not really a strawberry problem, but if you denude the roots of the beneficial microbiology, so the bacteria and fungi and protozoa and all the things that are living down there, do you think you see some other things coming back?
So, you can think of the soil as being being an ecosystem like anything else, and you have sources of energy, and you have, organisms trying to use those sources of energy. So when you add soluble nutrients to a farm field, and you've broken that symbiosis, well, let me start with, when there is a symbiosis, there's the rhizosphere, which is, a millimeter coating along every root, right? That is regulating the interchange of sugars and nutrients, but it's also like a shield. It's protecting the root from other things, because there is this bacteria, there's these bacteria and these fungal things that are protecting their source of energy from other things. Once you've broken that symbiosis, that plant root is now what's there to feed on in the soil.
Right.
The plants are no longer putting their sugars down. There's nothing protecting the plant's roots. The only source of energy in that soil now is the plant's roots themselves.
Right.
So, all of a sudden, what you had before, where you had disease resistance and, your own beneficials kind of taking care of these diseases for you, now you don't.
Right.
So it's just that much easier for a disease to come in. And so, the symbiosis between the mycorrhizal microbiota, which is both fungal and bacterial and invertebrate, if you go that far, and the plants, is really the basis. And it's the oldest say in organic farming, but it's the least understood in a lot of ways as well.
I would agree with you, and I think in many ways that's fed sort of the regenerative ag movement, because you go back to old school organic like old Rodale texts, like 1940s, 1950s, or Sir Albert Howard, or these other, big early organic proponents, and they talk about this stuff. I mean, they might not have had they didn't have the electron microscopes and some other stuff to really visualize and understand what's going on, but they saw the pattern in the field, and they said, well, if this is what happened, you do this, and this is what happens. And but it really is really interesting how it's really hard for us to seem to hold on to that idea. So we keep going. To me, I look at regenerative, and it's like, okay, well, this is just the next cycle. We're being reminded again that this is important, and I guess we just need to be reminded again.
Well, I have a different take on regenerative, just because it's not defined.
Well, that's the other side of it. It isn't. Yeah.
So, anybody can define regenerative as anything that they do. So, people are defining regenerative as not using tractors, but spraying godzillions of, gallons of Roundup in their field.
Well, yeah, Midwest. No-till,
so, you know what I mean?
GM, Roundup, yeah.
So I got...
but no tillage.
So regenerative to me is worse, is not a great word to use, even though organic is regenerative, because it's just, I don't like using it at all, in the sense that it puts organic producers on par with people that just have no business being anywhere near that word, you know, anywhere near the regenerative part of that word, you know what I mean? So it's an undefined word, and it's basically up to who has the best marketing department. And that's not organic farmers, that's not small-scale organic farmers for the most part. So regenerative is going to be a word that is defined as, it's going to be defined as, or it's not going to be defined, but it's going to be used as a greenwashing term, almost strictly. In 100 ways, it's going to be used for greenwashing. So I really don't like that word at all.
Yeah, it's interesting. Yeah, I've had a similar response over the years, and I've been really happy to see, CCOF's been pretty involved in this, but the regenerative organic certification, because it at least, it uses organic as like the first piece, which of course keeps out, it's like, well, no, you're not going to use Roundup. You can't. But yeah, it's amazing how many different marketing schemes there are out there, and how they are all pretty different.
And the other thing about regenerative is a lot of people have seemed to take it as just never till your soil. And
I've had so many conversations about this.
And for dry farm tomatoes, like, could you do no-till dry farm tomatoes?
No.
You're right.
But it's also, what might be a regenerative practice, in somewhere that's dry, and deserty, and not tilling, that might be the best way to use that parcel for the planet.
Right.
In this area, not tilling is nowhere close to the best use of this land, because you can grow these big cover crops and you can disc them in every year. You can build the organic matter in these soils, which would, bring carbon from the air into the ground, and it has all kinds of good things. But not if I don't till, plus in this particular area, we have enough moisture that even if you get weeds all summer long, we have gophers. There have been a couple of places that I've heard of, regenerative no-till systems, organic systems being successful, but very incredibly specific cases.
And that's what I've seen too. I mean, with roller crimper approaches and things like that, if you're in a place where you can get a predictable cover crop, and the crop you're growing is one that will enjoy that system, then it can work. Where you don't get a good cover crop stand, it's a nightmare.
Yeah.
I mean, it's way worse than not doing anything, because of weed breakthrough and then difficulties with horticultural practices and just everything else. So that's fascinating.
The ones in California that I've heard, though, they're such specific cases. One was, Dave Park up in with the processing tomatoes.
Yeah, is it full belly or?
No. It's Park Seed. No, not Park Seed. It's Scott Park.
Oh yeah.
Scott Park with the tomatoes up in. He has processing tomatoes that he grows, and I was at the Eco Farm a couple of years ago, and I raised my hand, and I'm all like, it was actually for the other guy that had the other thing. I didn't raise for Scott Parks, but what like we couldn't do tomatoes in that same way because, our gophers would come through, and we had meadow vole population a couple years ago that was bad. And I was just like, but he irrigates his tomatoes by flooding them, by flooding the field.
Irrigation.
so you don't have to worry about burrowing mammals if you're flooding your field because they all die. So I don't flood my fields here. I can't, do that. The other one was growing these brassica, like the broccoli, the baby broccoli.
Yeah.
And and I raised my hand and I'm asking him like, well, don't you have, don't you have vertebrate, gophers and stuff? He's like, no, we don't really have problems with that. And then he goes on and he talks about how his soil, the soil they've been growing it on for 100 years, conventionally previously, and it's all DG.
Yeah.
So of course, DG, like trying to burrow through DG would be like burrowing through, Brocket Fresh, right?
Yeah.
So again,
Some with them.
there were two very specific examples of no-till things kind of working organically in this area, but in such incredibly specific ways that they're making them work that aren't, just aren't transferable out to here.
Yeah.
But for me, that's always been the sort of wonderful thing about organic production is how, I've always felt all farming is local, right? If you apply a conventional tool set to it, you can kind of delocalify it, right? Because you're homogenizing the environment to fit your vision of what that plant needs. But as you move into more, relying on biological systems, well, whatever's there is what you have to work with. And it's extremely local. So so just like you couldn't grow dry farm tomatoes up in the Salinas Valley, I don't think. I don't know if it would work.
Yeah, I don't know.
I don't think the environment's right. I don't think you've got I think it gets too hot in the summer probably compared to here on the coast. And you don't have the coastal fog that provides a little bit of extra water. So I'd be pretty surprised if you could, but you can do it here, right? And it's an amazing, wonderful thing.
Well, and like when we first started here, we were getting, we're probably getting 2 times the yield that we were getting over in San Jose on the dry farm tomatoes. But the San Jose is much warmer, than here. But now we have switched it where we're getting better yield in San Jose than here now on the dry farm. And it actually, I don't know, I'm getting way too much, but I'm pre-irrigating my dry farm land.
Oh, okay.
So, because the one year that we got the best yields over there was 2021. We had the huge winter. And yields over there beat the yields here for the first time ever.
Yeah.
And now we just pre-irrigate over there in the wintertime.
Well, you're charging the soil, right?
The soil,
Charging all those pore spaces so that's your reservoir. That's awesome. So we talked a little bit about nutrient management, or you've talked about soluble nutrition. What are you all doing? So you obviously use cover crops as part of your nutrient management program. What are other aspects of your nutrient management program?
We have mostly the compost, but now our compost vendor went to worm castings.
Really?
So, he just makes the same compost he's made that I've bought for 20 years, but now he runs worms through them for whatever, a month or 2 months or whatever, and then pulls the worms out. So right now in the soil, we're using worm castings, gyp, and these on the coastal locations we'll use lime to bring the pH up. And then we always add a little bit of, like a pelletized true, I think it's 1300 sometimes, and sometimes 757. But just kind of small amounts of those to kick the stuff off. The worm castings, often we'll see more fertility in second and third year from the worm castings than the first year.
Interesting.
Because it takes so long to break it down. So we, when we're planting, for instance, over in San Jose, we're having, the soil is very different than the coastal soils here. It's alkaline and it's heavier and it has too much magnesium. There's a lot of problems. We could go to a whole podcast about that soil. But we've added gypsum over time to bring the calcium up, and now we have a very productive soil over there. But it was also very interesting because when we started, there was a really high organic matter, and that was one of the last things. One of my latest things a couple years ago was, it's a lot of people use in organic agriculture, a lot of people use organic matter as, well, if you get the organic matter, that's all you need to do.
Right.
It's not true.
Yeah.
The organic matter is just a feedstock for your soil biology. So you can have a very strong field with with less organic matter, but if it has a strong biota, your plants will do great. Okay. And when we were over there, we came there and we had 12% organic matter.
Wow.
But
that's huge.
Yeah.
For California, that's enormous.
But guess how much, but nitrogen was in single digits.
Okay.
Phosphorus and potassium both in double digits.
Oh, wow.
So there was no available nutrients.
Right.
So what I learned over there is that, you really need both heat and water in order to have a successful organic system at at some point in your cycle. Here we have very little heat, but we always have a lot of water.
Okay.
Over there, it was baking dry every summer. There's just not that much rain, so it would bake dry. So there was no organic, there was no organic system in the soil, no organic microbiota to process those nutrients. So we started adding gyp and compost, and as we started farming it, and it got wet, when it was also hot, we broke down. I mean, we went down 3, 4, 5% organic, matter points, down from, it was varied. It was, some areas was 12, some areas was 9, but we lost, 3 to 4%.
Right.
But over, maybe 4 or 5 years, but we've been there almost 10 years now. So now we're back up to the original organic matter.
Oh, really? Wow.
So, but it was only in the areas that we're actively farming, right? And there's other areas that we haven't really had the money to redo and the labor to farm anything on anyway. So, it's over there we have some really great soils that are really active right next to soils that have never been amended.
Yeah.
So, so heat and water together can break down that organic matter into nutrients for your plants. But if you bake that soil dry, and I've done a lot of, all my soils now at all my ranches, for the most part, have really strong microbiology, but you can lose it. If you can bake it dry, you can get it flooded, and those really affect the yields. At one of our properties that got flooded 2 years ago up in Leveille, 2 years before, we have this 2-year rotation of dill and cilantro up there. We got great yields, 10,000 pounds an acre across this whole field. And then we did it in a different place, and then we came back right after the year that it flooded. And the way the field flooded, it was wet for maybe 2 weeks on the edge, kind of on the road edge. And then as it got closer to the mountains, it was wet for 3 months or whatever. We started picking on the road edge, getting great yields using the mechanical harvester. By the middle of the field, we couldn't use the mechanical harvester anymore. We had to harvest by hand. The last 2 blocks we didn't even pick. We had to go back through and pick the good stuff again the second time. And what was happening is that field was homogeneous before, but because it had sat for so long, it had changed from aerobic to anaerobic, and totally messed up our production for that year. So now I'm much more careful if anything gets flooded about, oh, hey, I got to let that rest for a few years, grow some cover crops on it, get that biology back into the soil. So, those very old organic sayings are very relevant, but very misunderstood.
Yeah.
I guess is what I would say.
You mentioned Cal Poly before. What is the connection that you have with the school, the farm's connection?
Well, we lease here. And this is Cal Poly Foundation, which is, associated with the school. And then, we'll give tours like this. And there was one year, I guess, for all of the ag students down there, we do offer training and stuff at the farm here. One year, we got I think 7 or 8 interns that came and worked with our crews, once a week, every week. But that was the most successful year. I don't know that we've had anybody since COVID come out, really. And then, and just a long-term partner other than that.
Yeah.
At times, I know there was talk about trying to grow things here for campus. But I mean, I think, by the time you get transport and everything, it's just really challenging and expensive.
Absolutely.
All right, well, that was a lot of fun. I learned a lot. Is there anything else you'd like to add?
I guess just that, all of the things that I've been talking about here don't make any difference if you can't do it economically. All farms have to be able to compete economically. And that's a big consideration when you're trying new things or new ideas or whatever. Will they fit in your system well? Will they make your system more efficient? Because all the farms have different markets or whatever, and a lot of the small organic farms that are around are direct to consumer or farmers markets or restaurants, and they have a price premium, so they can be a little bit more inefficient. But for us, we're really competing directly with agribusiness, and all of our, we don't do any farmers markets, we don't do any direct to retail. So for us, it's really about the economics of every single thing. How can we grow the way that we want to grow, help the soils, give people great food, while also being sustainable?
Yeah.
And that's hard because a lot of the, there's a lot of, unknown or unviewable, benefits to growing conventionally that you don't get, or that you don't have organically. You get more federal funding for, for all your research. You get, there's a lot of things that are not really tailored to helping the soil and helping people be healthy, I guess. But it's all based on economics, so you always have to be, whatever you do, and it has to be sustainable and it has to be efficient enough that you can compete with everybody else.
Yeah. Well, thank you so much for letting us come out here and interview you today. Thank you again, Dr. Grieshop, for giving all your insight on everything you know.
Well, I just ask questions.
Program funding for the Organic Odyssey was provided by the California Certified Organic Farmers Foundation, as well as the Transition to Organic Partnership Program. The show was created by Matt Grieshop, the talent coordinator and resident organic expert, as well as Moses Mike, the faculty production lead. The Organic Odyssey is a production of the AGC 225 class called Digital Communications and Agriculture. The student team that produced the show included Natalie Eubanks and Savannah Taylor, the directors, hosts Madison Jasso and Ava Rose, storyboard editing by Avery Mulerath, and the technical team, Isabella Anderson, Vincent Biller, Vivian Kempora, Kendall Cook, Callie Granis, Carolyn Janes, Zach Collar, Emmy Lynn Marrow, Jack Oliver Roa, Sarah Purcell, Mason Riley, and Holly Rudnick. The guests for this episode included Greg Rawlings and Matt Grieshop. The Organic Odyssey is a digital media collaboration between the Agricultural Education and Communications Department and the Grimm Family Center for Organic Production and Research at Cal Poly. These credits were read by Chelsea Ann. Thanks for listening.